Okay, let's move into section 1.3 in the textbook. All right, I want to define the steps of how to solve a linear word problem for you guys. And I'm going to actually give you a few examples. This is probably going to be one of the longer PowerPoint presentations in this first week, only because I want to throw as many examples at you as possible. So those of you needing more help will have it. All right, so let's get going here. All right, let's start on the left-hand side where it says steps for solving. All right, and as I read it, I want it to resonate in your head. I want you to remember this forever and ever, at least until December 6th. And that first step says, read the problem. And then I tell you in green, I'm serious. Read the entire word problem. Because I know you guys, and what do you want to do? You want to scan it and you want to see the numbers, and somehow magically you want to try to write an equation without reading the words and picking out a few numbers. And folks, that's impossible. All right, so we got to read the entire problem. All right, and so let's start over here with the example as we go through the steps. All right, a salesperson receives a base salary of $35,000 and a commission of 10% of the total sales for the year. All right, this is very realistic. This is what we see when we're in sales. And our first agenda here is to write a linear model that shows the salesperson's total income based on total sales of K dollars. No big deal that they're using the letter K. We can use K. We could use X if we want. We could use any letter. All right, and so I'm going to define capital I as the salesperson's total income and little k as the dollars of total sales. And so when I go back up and read the first sentence of the problem, I see a salesperson's total income. All right, so what this person receives as their salary is going to be $35,000 plus 10% of the total sales. And so literally as I read the English, I can understand the math. The salesperson's total income is $35,000, the base, plus 10% of the total sales, or 0.10 times the total sales. All right, and so assigning the variable K to the total sales, I can rewrite this as capital I equals 35,000 plus 0.10 K. Then in part B, it asks, if the salesperson sells $250,000 worth of merchandise, what's her total income for the year, including her base salary? So that is a math word problem telling you to plug $250,000 into part A where you see a K. $250,000 is her total sales. And so $250,000, let's grab my pen real quick. $250,000 we're going to plug in right here. And you can see that's exactly what I've done. And so her total sales, or her total salary rather, is going to be 35,000 plus 25,000, and add that together and I get 60,000. And so for this particular salesperson, because of her total sales, she's making $60,000 as her salary. All right, let's go. Well, that's just wonderful. That little red do flicker down there. All right, let's take a look at this problem right here. All right, this is a typical geometry problem. Geometry problems for right now in section 1.3 are almost always going to involve perimeter. Perimeter typically gives us a linear equation to solve. We'll see later on, actually I guess next week in section 1.4, that when we're dealing with quadratics, that's when we get into area. But for right now, we're just going to worry about perimeter. All right, the key is changing the English to math symbols. All right, and so I have a problem. If the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of the original square. When you guys try to read that without drawing a picture, you do get lost. And as I read it to you, I'm sure many of you rolled your eyes or went, oh my heavens, how would I ever figure this out on my own? All right, you will figure it out on your own because you're going to draw a picture. I have an original square. it never tells me what the length of the side of that square is. So since I don't know, I'm going to call it x. And then I know I get a new square. And the length of each side of that new square is increased by how much? Well, the problem tells me 3 centimeters. And so I draw my original square and I draw my new square. Now I need to try to write the equation. I get the perimeter of the new square is 40 centimeters more than twice the length of the original square. All right, so what is perimeter for a square? Well, it's just 4 times the side, right? And so I get the perimeter, I'll grab my pen again, the perimeter of the new square, 4 times x plus 3 is my side, so that is why I get 4 times x plus 3 over here on the left. Is English for equals in math. All right, so I get my equal sign, and now I need to translate 40 centimeters more than twice the length of the original square. So I get 40 more than is plus, all right, we know that, and then twice the length of the side of the original square. Well, twice the length is 2 times the length. What is the length of the original square? Well, it's just x, and so that's where my 2x comes from. Now I need to solve this equation, all right? So once we get it in the equation, you guys will find, hey, these actually aren't too bad to solve. First step, distribute the 4, giving me 4x plus 12 equals 40 plus 2x. All right, now I want to try to get all my x terms on one side, all my numbers on the other. So I'm going to subtract 12 first. By subtracting 12, I get 4x equals 40 minus 12, or 28, plus my 2x. Now I need to move the 2x. Subtract 2x from each side, and I'm getting 2x equals 28. All right, lastly, isolate the x, means to divide both sides by 2, and I get x equals 28 divided by 2, or 14. All right, again, we don't want to leave it like this. This 14 means something to us. It's a word problem. All right, you wouldn't want to be a business major and make a PowerPoint after your boss has asked you to find something and make a PowerPoint slide that says x equals 14. That's silly. All right, 14 means something here. What is 14? 14 is the side of the original square, and it has the unit of centimeters. And so each side of the original square measures 14 centimeters. All right, this is very typical to what you guys are going to see in your homework. After a 40% price reduction, you purchase a new laptop for $840. What was the computer's price before the reduction, or what was the original price? All right, well, we have this original price. We don't know what it is, so we're going to call it X. And how much are we subtracting off? 40% of the original price. So that's where we get the X minus 0.4X. Right? And what is the reduced price? It's $840. And so this is how we're taking the English and putting it into math terms. All right, again, original price X minus 40% of the original price is the reduced price. All right, and so we have our linear equation. We need to solve this. We can combine the terms on the left side. All right, we have 1x minus 0.4x. Think of this as $1 minus 40 cents. Gives us 0.6x, or 60 cents x. All right, I notice a lot of times turning it into money helps you guys see the decimals a little bit better. All right, so again, we now have 0.6x equals 840. divide both sides by 0.6, and we get x equals 1200. Again, this is a word problem, and so we can put this into English and say the original price of the laptop was $1,200. All right, one more example. I know you guys are probably getting tired and you're certainly getting bored with me, but let's do one more that will be very similar to some that you see in the homework as well as on the quiz. All right, so you're choosing between two texting plans. And again, guys, this is normal math. This is the math, when I say normal math, it's consumer math. All right, now we may not be doing this as much for texting plans nowadays, but we certainly do this for our data plans. Which data plan is better for us in the long run? All right, so let's think about this. Plan A has a monthly fee of $15 with a charge of 8 cents per text. Plan B has a monthly fee of $3 with a charge of 12 cents per text. For how many text messages will the cost for the two plans be the same? All right, so cost of Plan A is $15 plus 8 cents per text. All right, so notice we have the 15, the cost of the plan, plus 8 cents per text just means 0.08 times x. All right, we can do the same thing for Plan B. The cost of Plan B is $3 for the plan and then 12 cents per text, which means 0.12 times x. All right, now again, we want to know when they're the same. So the monthly cost for Plan A, we take the linear equation 15 plus 0.08x, must equal the monthly cost of Plan B, which is 3 plus 0.12x. And now we have our linear equation we want to solve. And how are we going to solve this? We're going to start by subtracting 3 from both sides, giving me 12 plus, just copy my 0.08x equals 0.12x. And now I want to move the 8 cents x, so I minus that from each side, and I get 12 equals 0.04x. Last, I want to isolate the x, get it by itself, so divide each side by 0.04, giving me x equals 300. Again, guys, what is this 300? It means something to us. They're text messages, right? And so at 300 text messages, the two plans cost the same.